So say NPN transistor, common emitter configuration. NPN transistor, and I'm applying common emitter configuration. And yesterday we have seen the circuit, okay, that this is my common emitter configuration. Here, say I have a resistance RC, and I am applying here, say a BCC RC. Here, say resistance is RB, and I'm applying here a voltage, say VBB. Okay. Now current is coming like IC, IB, and IE. Now, what do you mean by output characteristics? Output characteristics means output characteristics. How to draw output characteristics? Output characteristics is basically you measure VCE. Okay. So VCE versus IC curve, keeping input current constant, is called output characteristics. Now all the three currents are interlinked. Okay, it is not if you apply VCC here, IC will flow. Until IB doesn't flow, this IC will not flow because IC and IBs are interlinked. The relation between IC and IB is beta IB. So now suppose you apply some IB. Okay, so initially IB is 0. So if your IB is 0, so your IC is also 0. If this curve is for IB 0. If IB is 0, then IC also 0. The only reverse saturation current flows. So only ICO flows. And now if you slowly change the value here, the IB will increase, voltage drop will increase here. This is voltage drop fixed. This is changing. This is fixed. This is changing. So IB is changing. When IB changes, so IC will change. So I told you yesterday, so suppose my IB is say 10 microampere, and I say my beta is 100. So IB is 10 microampere, beta is 100. So the IC will become 1 milliampere. For this IB curve, IC value will be 1 milliampere. And similarly, if I keep on increasing, if I say IB is 20 microampere, this will be 2 milliampere. And if it is 30 microampere, this will be your 3 milliampere. This is the output characteristics curve. Okay. And now output equation says that VCE should be equal to VCC minus ICRC. Okay. So your operating point, your VCE and IC, these are the operating point, VCE and IC. This is the operating point Q. And this always lies on these curve. Okay. So these curve plus this should satisfy this equation. And this is the line equation. This equation, if I draw, this comes like this. Now your operating point has a fixed VC, IC plus IB. So three points. So one of the graph, your operating point should stay. Okay. Suppose it can be here, it can be here, it can be here, it can be here. Suppose your operating point this one at IB is 10 microampere. Then the corresponding current will be this one. Whatever current is flowing here in corresponding to this graph, that will be IC value, and this is your VC value. This will be your VCE value. Okay. And these are the endpoints. IC saturation, and this is the VCC. So this is the VCC. So this is the VCC has to be greater than 0.7 volt. Okay. Or roughly you can say VC should be greater than your 1 volt. Then only you will be in the active region. Otherwise, you will be in the saturation region. Okay. And I told you the one more method, you just find the IC value. If IC is less than IC saturation, you can make sure that your IC, you are in active region. either VC is greater than 0.7, make sure that VCE, this is a VCE is equal to VCB, this VCB plus VB. If this is greater than 0.7, this VC is makes this VCB positive, and VCB positive means this is a reverse bias. This is a forward bias, this is a reverse bias. So this is the active region. Okay. So always check either IC value or VCE value to know whether it is the active region or it is in the saturation region or a cutoff region. Okay, cutoff region, for cutoff region, this IB should be 0. Deepak, is this point clear now?
Yes, sir. Yes, sir.
Okay. Now we'll solve some problems. So we have a battery, say 10.7 volt. This problem came in CSIR net. June 2015. Okay. Now this is my transistor. This is like this. This is 10 volt. Okay. And this is 2 kilo ohm. Now beta value is 100. Find the operation region and operating point. निकालो. 100 kilo ohm and 2 kilo ohm. Okay. Now first off, कैसे करोगे अमरदीप? How to approach this problem? कैसे करोगे?
So first of all, we have to calculate here the IC.
Yes,
IB then IC.
Yes, very good. So first you calculate IB and then you calculate IC. IC means which is going in the C terminal. IB means which is going in the this terminal, and this is E terminal. So current coming from E terminal is IE. So IB will be, so you have minus 10.7 volt plus IBRB. Okay, or I say whatever. So directly I can write IB. IB will be 10.7 minus BB. You take 0.7 minus 0.7 volt in this equation, divide by 100 kilo ohm. So this comes out 10 upon 100 into 10 raised to power 3. Okay, 10 cancels. कितना आएगा? 10 milliampere. 1 milliampere, huh? 1 milliampere. So divided by 10. 1 or how much? Tell me.
2.1 milliampere आएगा.
It just becomes C. 10 is of 4 and 10 is of minus 10. So it is coming 0.1 milliampere. 100 microampere, huh? 100 microampere. Now, just 1 minute. you can change this value because this should be 10 kilo ohm, no? I put 10. This is 10 kilo ohm. Okay, sorry. This is 10 kilo ohm. Now you can check it. Okay. So this is 10 kilo ohm. So now how much will become? Tell me. 1 milliampere. 10 cancel. So this will be 1 milliampere. Now this 1 milliampere current is very high. Whenever IB is generally microampere, जब भी ये ऐसा value आ जाए, you should always doubt that why it is coming so high value. Okay. So now IB is there. So you can find the IC. IC value is beta IB. Beta IB means 100 into 1 milliampere. This is 100 milliampere. This is too high current. High current means going saturation. Now you find the IC saturation. IC saturation will be what? IC saturation will be always make VC 0. So VCC upon RC. VCC upon RC is IC saturation. 10 upon 2 kilo ohm. That is 5 milliampere. Okay. Now my IC is greater than IC saturation. IC is the greater than IC saturation. That means now this is the what? Saturation region. This is what? Saturation region. Now IC cannot be greater than IC saturation. So the maximum current can flow in the circuit is what? Maximum current कितना flow हो सकता है? Maximum current
5 million.
5 milliampere. So this is not the actual value. So this is the actual value, 5 milliampere as saturation. Now you can find your operating point. So operating point is very easy. How to find the operating point? VC is, so if I find VC equal to VCC minus ICRC. Now VCC is your 10 volt. IC can be 5 milliampere. You cannot take this value now because this is greater than. So actual value is 5 milliampere, and then this is your 2 kilo ohm. So VC becomes 0 because 5 milliampere means came only when we put VC is 0. Saturation means VC is 0. So now my operating point is what? My operating point is this one. 0 and 5 milliampere IC saturation. This is my operating point. And this is the saturation region. And this says the current is 100 milliampere. If I take this value of current, this value current, and if I put in this equation, then my VC will come positive or negative. If I take this 100 milliampere current, okay, in this equation, then my VC will come positive or negative.
So negative.
Negative आ जाएगा. Current is coming very high. It will be so negative. But negative it cannot be happen because here I am applying only positive only. So this can be only positive. This drop can be here and here. So this cannot go beyond. This can be almost zero, at most zero. This cannot go negative. That's why we are not taking this current. Maximum current can flow equal to IC saturation. So this is your operating point. Now operating point is 0, 0 into 5. This is your Q operating point. Always remember this one. Okay. So this is working in the saturation region. Now this point should be clear to everyone. If still there is any student who is not getting, please tell me, because now we are going to do only these kind of things only. Okay, different kind of circuits. Now next is your same circuit. If I make this battery now 5 volt, battery this is 5 volt, beta is 10 kilo ohm, beta is 10, and rest thing is same. This is 10 volt and this 2 kilo ohm. Now you find the operating point and region of operation. I reduce the beta value and battery. Tell me now the values. IB is 10 kilo ohm. Make it 1. This is also 1. Find out the operating point.
Sir, IB is 0.43 milliampere, sir.
Yes, yes. Yes. Okay. So IB will be 5 minus 0.7 upon 10 kilo ohm. So 4.3 10 raised to power, that is 0.43 milliampere. Now IC will be
4
10
milliampere.
0.43 milliampere, that is 4.3 milliampere. Now if you know, now compare with IC saturation. IC saturation is BCC upon 1 kilo ohm. That has become how much?
10 milliampere.
10 milliampere, which is greater than IC. So this is the correct value of current in the circuit. And now you can find a VCE is equal to VCC minus IC RC. VCC is your 10, IC is 4.3 milliampere into 1 kilo ohm. This cancels out. So this is your 5.7 volt. So now this says that operation region is active. Okay. VC also 5.7 volt, much greater than your 0.7 volt. So this is the 5.7. 0.7 is there, 5 is there. That means this is the reverse bias, and this is forward bias. Current is flowing. So this is active region. Okay. That is forward bias and reverse bias. So this is that operation region is active. And operating point Q is 5.7 and 4.3 milliampere. This is the operating point. Now you understood that at least you have to apply two biasing. Okay. You want to make your transistor work in certain region. Whether you want to market ये इसको काम करना है, एक्टिव में काम करना है, कट ऑफ में काम करना है या सैचुरेशन में काम करना है, everything will be decided by these two batteries. To the biasing, how does biasing occurs across these two junctions? Okay, so you need at least two batteries. Now if you see any electronic device, okay, for example your computer or any electronics device, that device contain hundreds of transistors, okay, hundreds, thousands of transistors. Now it is not possible that I should give each transistor two battery. This is not practical. Okay, because suppose your laptop you have only one battery now, and with the one battery you are giving power to your all board. So this is not practical that every transistor has a two battery. This is not a commercially feasible way to do biasing. Okay, so so generally, so there's a different ways of biasing where I will choose only one battery, and with one battery I can give the biasing to hundreds of transistors. Okay, so this is not a practical. So first of all thing, what is biasing? Now the next for operation of transistor, you need to apply the biasing. This is the principle. Okay, fundamental first principle biasing. Okay, but actually this kind of biasing is not practical because you cannot apply two batteries to every transistor. Okay, but batteries are very costly. And maintenance is difficult, na? Okay, so you have generally one battery, and one battery will be connected to the hundreds of transistor. So, and biasing, without biasing, you cannot work. Okay. Why biasing? So what? So first of thing, why biasing is required? Okay. Why biasing? Why biasing circuits are required? I'm talking about DC biasing. So biasing is required. First of all, I want transistor to work in active, cutoff, or saturation region. Okay. So biasings are required. Number one point to fix the operating point. To fix the operating point, I want to fix my operating point. Okay. Q, to fix the operating point Q. That my according to my application. Now, second thing is this operating point is a function of temperature. Okay. Function of temperature means your IC is depend on temperature. So temperature means because your IC is formed with ICO. So reverse saturation current is function of temperature. Beta is function of temperature. Beta. So if temperature varies, what will happen? Your IC will change. And if IC will change, what will happen? IC will change. That means your operating point automatically shift. Okay, your operating point automatic shift, and we don't want that operating point should fixed. So first is biasing is required to fix the operating point, and the second reason of biasing is the biasing should be such that to stabilize the operating point. That means operating point should not. This is my operating point somewhere. Say this is my operating point. And I have fixed this one with my biasing. Now some external effects, temperature, this should not change. This should not go here, because if it is going here, it will go saturation. If it is going here, it is going cutoff region. But I want to keep this operating point to be fixed. So my biasing should be such that first it should fix the wherever I want, and then my biasing should make sure that this should not change with increase with change in the temperature or some other problem in the circuit. This should not deviate from its position. So that is also purpose of biasing. Okay, and the third point is what?
Excuse me, sir.
हाँ.
सर ऑपरेटिंग पॉइंट मतलब सर ये उसी पॉइंट मतलब कि सर सर्किट सर इससे ज्यादा करंट पे काम नहीं करेगा या फिर सर इसके लो करंट पे काम नहीं करेगा?
काम नहीं करेगा. सी मुझे ऑपरेटिंग पॉइंट को शिफ्ट करना, यहाँ रखना है, ये
अच्छा.
रखना है, यहाँ रखना है. ये तो मैं डिसाइड करूंगा ना मुझे कितना रखना है. एक्टिव रीजन में काम कराना है कि सैचुरेशन में काम कराना है कि ऑपरेट की कट ऑफ में काम कराना है. ये तो मेरे पे डिपेंड है बायसिंग पे. मैं शिफ्ट को इसको कहाँ शिफ्ट करना चाहता हूँ. एक बार मैंने इसको फिक्स कर दिया. ओके, नाउ ड्यूरिंग द ऑपरेशन इट शुड नॉट चेंज. अब ये चेंज कैसे होगा? सी फर्स्ट ऑफ ऑल थिंग, sometimes your laptop or your electronics devices get heat up. Okay, so what happens? Heat up means temperature goes very high. So what happens? Your temperature increases. Now your beta is a function of temperature. If temperature increases, beta increases, then your IC increases. Similarly, if temperature increases, your reverse saturation current ICO, that is also temperature dependent. Okay, that is also increases. ICO also increases with temperature, and ICU get add up in the IC, so it is also increases the IC. When temperature increases, your VBE, built-in potential VBE, which is 0.7, that also gets down. That's get down, but you have applied some voltage, and your IB is flowing. Now VB become down, so IB will increase. That means this VB will go down. VB will go down, and VB will go down means your IB will increase, and IB will increase means finally it will change your IC. The IC will also increase. So automatically this point I have fixed someone, but first I have fixed this one applying biasing, and now it is shifting because of these things are happening. Okay, and third and the most important thing is, so I want to make IC constant. Okay, so the overall purpose is to stabilize IC. Operating point means the overall purpose is stabilize IC. Okay. And the one important thing which I already told you, the commercial points. Okay. Batteries are very costly. Batteries are very costly. Okay. Maintenance of batteries is difficult. Maintenance of batteries is difficult. Now you cannot put 1,000 batteries in your laptop. Okay. That will commercially, battery is very costly. Commercially is not viable. Okay. So all this commercial aspect plus practical operation aspect. Okay. For this one, we need to bias a transistor. Okay. Now how to approach, how to bias with single battery, 100 of transistor. So there are some methods for biasing. Now put the heading biasing, DC biasing. Okay. So once you do DC biasing, then only you can amplify. So first you have to learn DC biasing, then we will learn the AC part. Okay. Shall I move the next? Shall I move? It is clear to everyone?
Yes, sir.
Now my biasing circuit should be such that it should keep watch on the IC. Okay. But now we'll start from the beginning. We'll see some elementary biasing, which does not control, which provides the biasing, but does not control the IC. Okay. So that is first elementary biasing is your fixed bias. Fixed bias means what you do, you have a battery plus VCC, you have a resistance RC, okay, you have here you have a RB, and this is your IE, this is your IC, and this is your IB. Okay. Okay. So this is elementary biasing circuit, and we'll see that we have to make, basically what we have to make temperature increases means beta increases, and beta increases means IC increases. But so we have to make IC independent of beta. Okay. So let us see whether IC is independent of beta or not. So now first thing, you have this is your input, this is your input, and this is your output. Okay. So we'll solve this one. So my this will be minus VCC plus IB RB minus VCC. This plus means what? This plus means this is the battery. While starting with minus VCC plus IB RB plus VB equals to 0. So IB will be VCC minus VB upon RB. Okay. So from input side, I can find the value of IB, and now output loop. Okay. Output loop I can find. So once I know IB, I can find the IC because the beta will be given. Beta is given. Okay. So my IC will be what? My IC will be beta VCC minus VB upon RB. Now see, IC is directly related to the beta. If beta increases, IC will also increase. Beta decreases in cold environment, IC will also decrease. So this circuit is providing the biasing. This is giving the forward bias here, and this is giving the reverse bias, this junction. NPN. N is plus reverse bias, P is P, forward bias. It is giving the biasing, but it is not making the biasing independent of beta. So if beta somehow changes, the IC will change. That's why it is called, this is elementary biasing. Elementary bias. Now, once you know the IC, you can find the VC. What we're doing so far, VC will be your VCC minus IC RC. So let us solve some problem based on this thing. Okay. So let us say my RB value is what? And the operation region, the way method of finding operation region is same. You have to find the IC saturation. Will be again here BC is 0, keeping VC is 0 in this equation. So this will be VCC upon RC. Okay. And you have to compare this one.
सर सर इसमें सर अभी भी सर बीटा पे डिपेंडेंट है ना सर ये अभी?
हाँ, बीटा डिपेंडेंट है अभी तो।
हाँ सर, प्रॉब्लम तो अभी मतलब सॉल्व नहीं हुई होगी ना सर?
प्रॉब्लम सॉल्व नहीं हुई है, मतलब भी एक तो पर्पज है कि बाइसिंग देना, वो तो दे रहे हैं ना, ऑपरेटिंग तो फिक्स कर रहे हैं।
हाँ
अब
सर।
अगर टेम्परेचर चेंज होगा, अगर सिस्टम में आपका बोर्ड हीटअप हो रहा है, तो तब आईसी चेंज हो रहा होगा। ओके, तो आपके सारे फंक्शन, ऑपरेटिंग पॉइंट हो जाएगा, तो आपके सर्किट के सारे फंक्शन इफेक्ट होंगे। ओके,
हाँ सर,
तो वो
मतलब
उसको,
एक, हाँ
हाँ
मतलब
उसको,
एक सिंगल बैटरी मतलब चेंज कर
हाँ
रहे हैं अभी मतलब।
हाँ, वो तो पर्पस पूरा हो गया। अब इसी को मैं 10 ट्रांजिस्टर को दे दूँ, 100 को ट्रांजिस्टर को दे दूँ, ये 10 वोल्ट मैं कहीं किसी को भी दे सकता हूँ।
हाँ
ठीक
सर।
है, तो ये तो पर्पस सॉल्व हो गया, बट अभी इंडिपेंडेंस का पर्पस सॉल्व नहीं हुआ है। ठीक है,
हाँ
so
सर।
say now I'm giving some values. Okay, or it's just like solving the circuit. So RB will be very high compared to the RC always. So say RB value is given 270 kilo ohm. Say VCC is 9 volt. Okay, VCC is 9 volt, and RC is 2.2 kilo ohm, and beta is 50. Okay, so find the operation region and operating point. BB is 0.7. Sometimes they may give it 0. Okay, so find operation region and operating point. Find operation region and operating point.
सर RB 270 किलो ओम है।
हाँ, 270 किलो में। बताओ कितना आ रहा है तुम्हारा, IB कितना आ रहा है, IB सैचुरेशन कितना आ रहा है?
So 0.031 milliampere IB is.
Okay, so IB will be, VCC is 9 volt. So IB will be VCC 9, 0.7, 270 kilo ohm. Okay, so this is become how much? 8.3, 270 into 10 to the power 3. So how much? 30 microampere almost. कितना है? 31. So I have answer 30 microampere almost.
So round off करके 31.
हाँ 31 तो जो भी करना है. So IC 31 से. So IC will be how much? 3.1 milliampere. कितना आएगा? 50 है. 50 है ना, IC बीटा इज 50, तो 50 इंटू 3.1 31 माइक्रो एम्पियर. 31 माइक्रो एम्पियर.
1.53 milliampere.
So 1.5, I'm taking roughly my 1.5. You take accurate, okay? 1.53. So 1.53 milliampere. And find the VCE, IC saturation. IC saturation. VCC कितना है? 9. RC कितना है? 2.2 किलो ओम. How much is coming? Tell me. Around how much? 4 milliampere? Huh?
4.1 milliampere.
4.5 milliampere. Okay. So my IC is less than IC saturation. So this is the correct value, and the operation reason is active. And now you can find the VCE, VCC 9 minus IC 1.53. ICRC is your 2.2 किलो ओम. ये कितना आ रहा बता दो.
5.7.
5.7 volt. Okay, 5.7 volt. Now the same question is homework for you with same values. Okay, only you have to you have to make beta now 150. You have to make beta 150, and you have to find the ratio of IC2 equal to IC2 by IC1. You have to calculate. Okay, same thing. Circuit is same, only beta has changed. So you have to find the operating point now, new operating point, and the reason of operation, and you have to find the IC2 by IC1. If you find the IC2 by IC1, it will come beta 2 by beta 1. That is 3 times. That means this circuit is not controlling your IC. Okay, not making independent beta, but biasing is there. Okay, so this is fixed bias circuit. Now you can change the values, many values, and you can shift the operating point. So now I'm going to now next type of biasing. So this is elementary bias. Now slowly we'll see some biasing which may be better than this one, and then finally we'll see which is the commercial biasing. Okay, practically used. So next is your collector to base bias. Collector to base bias. Collector to base bias means like this. You're applying RB. RB is same, but now this is my VCC. Now collector resistance is here. Here you have a collector resistance, and from collector resistance RC, you have a VCC. Okay, and now this is going here IC. Okay, this is your IB, and this is your IE. IE. This is my circuit. Press VCC, RC, IC, IE, IB, RB. This is collected to base bias. Okay. Now we have to discuss this one. Now, what does this kind of biasing do? Okay, let us first understand. Okay, we have to apply input loop. Okay, we have an input loop. So input loop we have minus VCC plus how much current is there in this RC? Tell me. RC में कितना current है?
IC.
Karishma, how much current is flowing in the resistor RC? Amarpreet.
IE.
IE, very good. Basically, the current is here because IB is going here, IC is going here. So here current may be IC plus IB. That is equal to IB. This is IC plus IB current. Total current is there. Okay. And now out of this current, the current which is going to the collector, that is IC. The current which is going to the base, that is IB. Okay. Always keep in mind while solving this one. So now I can write, but I am writing equation for input loop. So IC plus IB, how can I write? IC is your beta IB plus IB. So I can write this is a beta plus 1 IB current flowing here. For input loop, for the input loop, I don't want IC, na? So I have to remove this IC. So I am saying this current is beta plus 1 IB.
नहीं कहती थी कतार देनी है फिर गई ऊपर कहती गिल्ले हल्के कपड़े
हाँ
कुछ
very
नहीं
good.
कहती पीछे
बारिश हो रहा है किसका आवाज आ रहा है प्लीज म्यूट द माइक ओके सो this is beta plus 1 IB, okay? So now minus VC plus beta plus 1, okay, RC, IB, RC, and now this is beta IB plus RB equals to 0. This point is clear to everyone? Tell me or not? किसका माइक ऑन है तमन्ना उसका माइक ऑन है प्लीज म्यूट योर माइक तमन्ना तमन्ना कैन यू हियर मी म्यूट योर माइक सतीश उसे म्यूट करो
अरे बच्चे
कैन एनिमल मैसेज तमन्ना
जो मिट्टी में चढ़ चप्पल पहनी हो जो चप्पल पहन कर बाहर चलेगी झाड़ू निकाल
सतीश Can you make it quiet? So let us discuss now. So is this point is clear to everyone? Amardeep?
Yes, sir.
तो ये आपको लिखने आना चाहिए because I am writing this current is equal to beta plus IB current. Okay. So now I can find the IB is what? Plus VB also there here. Plus VB equals to 0. So my IB will be what? My IB will be VCC minus VB upon beta plus 1 RC plus IB. Beta plus 1 RC plus IB. And now you can find the IC value. IC value will be beta IB. So beta, now IB is VCC minus VB. And then you have a beta plus 1 RC.
Sir, I can't understand the equation, first equation.
So that's why I'm asking you, that time you didn't tell. What is this equation? Minus VCC plus IB plus IC RC. Correct?
Okay, sir.
So IB plus IC RC and IC plus IB. How can I write? Plus IB RB plus VB equals to 0. Okay. And now IC is what? Beta IB. So minus VCC plus IB. IC is your beta IB. RC. I'm coming from like this, na? Loop. IC is beta this one, and this is your IB, RB plus VB equals to 0. So what are you gonna take? IB common, it will become beta plus 1. So IB will be what? BCC minus VB beta plus 1 RC plus IB.
Got it, sir. Actually, sir, that path, that single branch is considered as a single loop, right?
Yes, you start with the battery and you go to the ground. This becomes loop, na? You start with the battery. This is grounded, na? Minus means what? This voltage is there. That means this is the grounded. You start with the ground and you go to the ground.
Now I have cleared. Okay, thank you.
So you go ground to ground. This is one loop. Okay. Basically, you are coming from one ground to other ground. This is a loop. Similarly, this ground to this ground. This is a loop. Now you have IC. Okay. Now you see if this IC is beta independent or beta dependent.
Yet it is beta dependent.
It still has a beta dependent, but now here denominator also beta plus 1, some fraction is there, na?
Yes,
See,
sir.
so earlier it was only proportional, but now some beta plus 1 is here, here also there. So this is
Yes, sir.
not perfectly good biasing, okay, but still this keeps some check on the IC, because if beta increases, this beta also increases. The ratio doesn't go exactly proportional. Suppose in the first case, if beta becomes three times, IC also becomes 3 times. Here it is somewhat different. If beta becomes 3 times, so IC will maybe become 2.7 times or 2.5 times, not exactly 3 times. There is some control over IC. Now, how does this control is happening? You can understand in this way. So now let us say your temperature increases because of some reason. Okay. And now this will increase your beta. This will increase your beta. This will increase your beta. Now when beta increases, what will become? Your IC will increase. Okay. Now if IC increases, this current will also increase. Yes or no? Tell me. If this IC increases, this drop will also increase. So if IC increases, then what will happen? Then the drop across RC will also increase. The voltage drop across RC will. That means now the potential coming here will decrease. And this point is called VC. This point is called VC. You directly connected to this is VC. Okay, VCC. This is drop here, and this is VC. And V is 0, so this is VC by VC also equal to VC. So this point VC, so VRC go up, this drop goes up. That means what happens? Your VC goes down. Your VC goes down. This point. If VC goes down, obviously the voltage drop across VRB goes down or up. If this point becomes less voltage, here drop will be more or less. अब इतना बताओगे ना? If this voltage is down, this drop will increase or decrease?
So decrease.
Decrease, because this voltage is going here and here, na? So this is fixed. So this will decrease. So VRB will decrease. VRB will decrease. Now, if VRB will decrease, then IB will also decrease. Yes or no? Because VRB equal to IB into RB. If this is decreasing, IB is also decreasing. And if IB is decreasing, automatically IC is also decreasing. So yeah, either you understand in this way or you understand this way. This circuit somehow keeps some check on the IC. Okay, not exactly, it is not independent, but there is some check is there on the value of IC. Okay, now let us understand this with some example. अभी ये अगर डाउट डायग्राम क्लियर नहीं है तो यू कैन आस्क मी अगेन. I will repeat again. Okay, but it is self-explanatory. T increases, beta increases, IC increases. IC increases, this drop will increase because IC is flowing here. This drop is increasing, that means this point is decreasing. This point is decreasing, that means this drop is decreasing. This drop is decreasing means IB is decreasing. IB is decreasing means IC is decreasing. Okay. Now, say in the same circuit, your VCC is 10 volt. Okay. And RC is 500 ohm. RC is 500 ohm. Okay. RB is 500 kilo ohm. RB will be very high emish compared to IC. 500 kilo ohm. Okay. And now you have to find, you can take VB value, VBE 0 for simplification problem, and you take beta value. One time you take beta value as, say, kitna diya beta 100. You say beta 100 and you say beta 2 300 second time. Okay. Solve the circuit, find the operation region, case 1 and case 2. Okay. So this is case 1. And if you change the beta, this becomes case 2. Both the cases you find the IC value and operating point and operation region. Find out. So let us solve. First thing, IB will be equal to what? Formula you already know. BCC minus VB is 0. VCC minus VB is 0 plus beta plus 1 RC plus RB. So this is 10 minus 0. Beta is 100. First case. So this become 101 into RC value is how much? 500 ohm plus RB value is 500 kilo ohm. So this become 10 upon, this is 500 kilo ohm, and this is how much? 50 kilo ohm, around 50 kilo ohm. Okay. This is almost, if I say, if I neglect one, this becomes 100. This is 5 kilo ohm. Okay. So I am writing this is basically 550 kilo ohm. Tell me what is the values coming? What is the value of IB?
microamp.
I have 1.8, 1.8, maybe 18.
1.8 है sir.
1.8165 microampere. Okay. So this is IB value. Now you find the IC value. Find the IC saturation. Second
Screen
case.
is blurring.
So IC value will be beta. Beta is 100. So tell me how much will come. This will be how much if I multiply by 100.
Sir, okay sir.
Tell me. This is microampere, na? So 10 is to 6, 10 is to 6, 10 is to 4.
0.1 sir, 0.18 milliampere.
श्योर 1 ही आएगा. अगर 100 से मल्टीप्लाई करेंगे तो क्या हो जाएगा? ये 10 to power 4 हो जाएगा. 10 to power 4. ओके. तो 4 multiply by 3 divide by 3 कैसे? और कम जाएगा ना?
सर 0.18 माइक्रोएम्पियर होगा.
मिली एम्पियर होगा. If this is 1.8, then it will be point. If it is 18, then it will come 1.8. You have to check it. You tell me whether which is correct. So I think it's 18 or 1.8.
मेरा तो 0.18 आ रहा है
सर
हाँ
आईसी की वैल्यू मेरी 1.8 आ रही है मिली एम्पियर।
आईसी की वैल्यू कितनी आ रही है 1.8
1.8 मिली एम्पियर मेरी।
और ये कितना आ रहा है ये आ रहा है
1.8।
ये आ रहा है क्या
नो सर।
कितना आ रहा है
0.18।
अरे भाई अब सबका अलग कैसे आएगा ठीक है मेरे पास भी आंसर जो है आईसी है 1.8 मिली एम्पियर ये आप चेक करो क्या हो सकता है गड़बड़ सो 1.8 1.816 okay now if I multiply by 100 1.8 this is 10 to the power minus 6 6 है कि 5 है पहले तो ये बताओ so this is 10 10 to the power minus 2 so this is basically 550 kilo ohm okay so this is 550 is 5000 this is if I say this is how much 100 this become how much 5 50 1 2 3 4 so 4 means 50 into 10 to the power 3 not this 4 so this is 50 kilo ohm 550 kilo ohm it is correct and this is 10 so this is 10 now this become 1 by 50 into 10 raised to power minus 2 okay tell me now कितना आएगा ये बताओ अब सॉल्व करो बताओ कितना आएगा if you it is 500 this is a 0.2 huh? 500 means how much will come if it is 500 1 by 500 how much will come 0.2 10 is 2.2 to 10 is power 4 minus 4 so if I make with 6 तो ज्यादा आना चाहिए करंट बताओ कितना आ रहा है 1.8 आ रहा है कि 18 आ रहा है
तो 0.18 मिली एम्पियर आ रहा है।
जीरो मिली एम्पियर आ रहा है ऐसा बोलो ना
हाँ जी
0.1 मिली एम्पियर
हाँ जी ऐसे आ रहा है।
सबका ये आ रहा है 1/55 1/55 मिली एम्पियर 0.1 मिली एम्पियर सो नाउ मल्टीप्लाई बाय 100 सो आईसी विल बिकम हाउ मच 18 मिली एम्पियर
18 मिली एम्पियर।
हाँ तो बाकी लोग भी चेक करो 1/51 कितना होता है भाई 1/51 होता है आपका 1/50 कितना होता है 1/50 आपका होता है 0.02 होता है आपका तो आपका 0.02 तो ये कैसा आएगा ये आना चाहिए आपका 0.01 ये आएगा आपका
यस सर यस सर
हाँ
ये आ रहा
हाँ हाँ तो आईसी अब आ जाएगा 1.8 मिली एम्पियर अब
है।
कैलकुलेशन में
यस
भी तुम ऐसे गड़बड़ करोगे तो कैसे काम चलेगा कैलकुलेटर लेके बैठे हो फिर भी so this is 1 point now it's correct okay and now IC saturation is what your IC saturation is your VCC upon RC okay VCC is how much 10 RC is how much 500 ohm okay tell me how much is coming
20 मिली एम्पियर।
20 milliampere okay so 20 milliampere no my IC is less than IC saturation so the operation region is active okay and the second case what will happen second case you have to find VCE VCE is your VCC 10 minus IC 1.8 milliampere RC 500 ohm so 10 minus कितना आएगा 500 ohm is 0.5 kilo ohm so 0.5 kilo ohm this cancels out this become 10 minus 0.9 9.1 volt ये आ रहा है क्या so my operating point become now 9.1 volt and how much 1.8 milliampere now the important thing is to remember that this is 9.1 volt it is close to VCE and whenever my operating point become close to VCE which region we are generally so the operation region is active but you have to keep in mind one thing that this is my IC upon BC curve this is my this one. This is my load line. This point is VCC. This point is IC saturation. And now I am getting my VC is 10 volt. But I am getting my operating point somewhere here, 9.1 volt. So although it is saying it is an active region, but it is close to cutoff region, because this is your cutoff region. When your VC become equal to VCC, when this current becomes 0, drop becomes 0, VCC become this VC, okay? So this VC is equal to VC, V 0. Okay, VC what? VC is equal to VC minus VE. Now VE is 0 directly connected to E is connected to 0, so VC is basically VC in this circuit. So this is, you are very close to the cutoff region. So sometimes the options they will be given, operating point is active region but close to the cutoff region. If this point is here, we can say operating point in the active region, but it is close to the saturation region if it is not in the saturation. So that time also options they make. Okay. So this is your first case. And now second case, when you make beta equal to 300, tell me what is the IC value? Second case. Case second, beta is your 300. Tell me what is the value of IC2? This is the first case. Second case, what will happen? Tell me. Whether IB will change, IB will not change because we have not changed anything. So IB will be same like 0.1 milliampere into this time you have 300. This is your IB value. It will not change. So now 1.8 into 3, how much will come? Tell me. 5.4 milliampere. Yes or no? Subhashish, Aparna, Amarpreet, are you getting what I'm saying here?
Yes,
Second,
sir.
second case,
Yes,
if beta is changed, so my IC changed, but IB will not change because this voltage, this circuit doesn't change. So now my next IC2 become this one, and now you can find the VC next operating point, and this is less than IC saturation. So now you can find the next operating point. Next operating point will be what? Next operating point will be VCE equals to 10 minus IC 5.4 milliampere into 0.5 kilo ohm RC value. This cancels out. So this is 10 minus 2.7. That is how much? 8.7 7.3 volt. Okay, 3 is 7, so 2.78 volt. VC will be 7.3 volts. So next operating point will be, this is the first case, second case, that will be 7.3 volt and 5.4 milliampere. Now this is somewhere middle, some of the middle of the region. Okay, we always have to, for best amplification, we have to keep my point here, somewhere here, not here, not here, not here. You have to keep almost, try to keep in middle. So this is your second type of biasing. Okay. Now there is a one more biasing we'll do in the 10 minutes. That is very easy biasing. Ammeter feedback bias circuit. Ammeter feedback. I'm erasing, rubbing this one. Tell me.
सर हमारा बीटा की वैल्यू चेंज होगी तो हमारी आईबी की वैल्यू भी तो चेंज होगी ना?
IB की वैल्यू कैसे चेंज होगी? IB तो सर्किट तो सेम ही है ना. IC depends on beta, IB doesn't depend on beta. Okay, your IC is beta IB. So if beta changes, gain factor. Okay, gain factor is depend on internal structure. Okay, because if you're increasing temperature, okay, somehow currents are increasing. Gain is what?
According to the formula, IB is equal to VCC minus VBC upon beta plus 1 RC plus RB.
Which what is there?
VCC minus VBE upon
VCC.
beta plus 1 RC plus RB. So beta तो आ रहा है ना डिनोमिनेटर में.
See, देखो BCC minus VB, okay, बीटा प्लस 1 RC प्लस RB, ये तुम्हारा IB का
Yes, sir.
फॉर्मूला है. ओके,
Yes, sir.
तो बीटा बढ़ने से IB बढ़ेगा या घटेगा?
फिर घट जाएगा.
घट जाएगा. और IC क्या होगा? IC होगा बीटा IB बीटा VCC माइनस VB अपॉन बीटा प्लस 1 RC प्लस RB. अब ये बढ़ेगा या घटेगा?
कम होगा.
ये कम क्यों होगा? ये बीटा मल्टीप्लिकेशन में है, ये मल्टीप्लिकेशन में थोड़ी ना है, ये बात थोड़ी ना है.
ओके ओके सर.
ये इसके साथ में है ना, तो ये ऐड होके ये इतना इफेक्ट नहीं करेगा जितना ये इफेक्ट ये कर रहा है. अगर ये यहाँ पर
ओके.
बीटा बीटा बाहर होता तो फिर ये घटता. अभी तो बढ़ेगा ही ना. ठीक है.
ठीक है सर.
हाँ, तो आपको वैल्यू मैंने तो उसे बताया, आप वैल्यू रख के निकालो. आईबी निकाल के देखो क्या आ रहा है. अच्छा, आप बोल रहे हो कि आपकी आईबी चेंज हो जाएगा यहाँ रखने से. हाँ, तो फिर आप बोल रहे हो कि इस फॉर्मूले में अगर मैं आईबी रखूंगा. हाँ सर, करेक्ट. आईबी डिड मिस्टेक. आईबी विल चेंज बिकॉज बीटा इज देयर ना. तो वी डन मिस्टेक हियर. प्लीज रेक्टिफाई दिस वन. दिस इज नॉट करेक्ट because this is not. So now change IB will change, but we have to see the effect. Okay, please calculate now new second case. Calculate the IB beta plus 1 RC. Case second, beta is 300. IB will be what? VCC 10 minus this is 0. This is now how much? 300. I'm neglecting one. 300. RC is how much? RC is your 0.5 kilo ohm. Plus RB is how much? 500 kilo ohm. So IB will be how much? 10 upon, tell me, this is a 500 and this is how much? 150. So this becomes 450 kilo ohm. Okay. And now this is cancelled. So this is 1 upon 45 into 10 raised to power minus 3. Tell me the milliampere, how much is coming?
0.02.
0.02. और थोड़ा ज़्यादा. 0.02 something. Okay, let's take it.
0.0222.
222. Okay, milliampere. Okay. So now you can find the IC. IC will be 300 into 0.022 milliampere.
तो 6.6 चला.
6.6 आएगा.
Yes sir.
Milliampere is correct now. And now you have to find new VCE. So VCE will be what? VCE will be your VCC 10 minus IC 6.6 milliampere into RC 0.5 kilo ohm. 10 minus 3.3, that is 5.7 volt. 5.7 और 4. कितना आएगा? 6.6, 6.7. 6.7 volt. Okay, so this is your new operating point.
सर ये IB इज इक्वल्स टू सर नीचे 500 है ना?
कहाँ पे
सर? ये ऊपर
ये वाला
IB.
ये RC.
हाँ सर.
हाँ 500 है ना. इसको मैंने दिया 0.5 किलो ओम. एक ही बात है, 500 हो गया.
हाँ सर.
तो ये हो गया ना, ये हो गया किलो ओम. ओके, ये 300. सो कितना हो जाएगा? 300 का ये 0.5 इंटू 300, 150 किलो ओम. दिस इज 500 किलो ओम. ओ,
तो 650 हो जाएगा ना सर?
हाँ, तो तुम ये बता, अब कैलकुलेशन में मिस्टेक करवा रहे हो तो क्या करेंगे हम लोग? 650 किलो ओम. अब कितना आएगा?
देख
1/65 10⁻³ कितना मिली एम्पेयर आएगा? 1/65 कितना होता है?
सर 0.015
0.015. ओके, तो अब नया आईसीपी चेंज हो जाएगा,
सर ये कर लेंगे सर कैलकुलेटर।
कर लेना तुम लोग, ठीक है। मुझे तो बताओ कि IC2 चेंज हो रहा है कि नहीं हो रहा है, बढ़ रहा है कि नहीं बढ़ रहा है, इतना बताओ बस। IC2 चेंज हो रहा है कि नहीं हो रहा है, निकालना। और IC2 VC2 निकालना, और रेशो निकाल के बताना कि IC2 बढ़ रहा है कि नहीं बढ़ रहा है। बढ़ेगा, टेम्परेचर बढ़ाने से बढ़ना चाहिए, ठीक है। चलो, कैलकुलेशन आप कर लेना। So let us stop here. अभी नया टाइम नहीं करने का। We'll do tomorrow new biasing. Well, this is easy, okay? Biasing part is very easy. So once you understand the biasing part, उसके बाद में next part होगा हमारा special circuits. DC biasing के साथ with DC biasing, how many different special circuits of transistor we can operate. And उसके बाद में once biasing is clear, circuits is clear, then finally we go to the AC part, okay? How to do amplification. So transistor circuits are very simple. You don't will find any difficulty in the solving transistor circuits. Okay. So I'll stop here. Thank you.
थैंक यू सर।